All right, so sine, cosine, and tangent, our trigonometric ratios, work well with right-angled triangles. However, not every triangle is a right angle. So what do you do in those cases? Well, this is where we can use the sine law and then later on the cosine law. So the sine law is what we'll start with, and it allows us to find missing sides and angles in non-right triangles. So when it works is important. It only works if you have two angles and their opposite sides in play. So here's the equation. You have a set of ratios where the side A over its matching angle, so A over sine A. Okay, so then this is how triangles are labeled, that the angle and its opposite side are always labeled with the same letter, capital on angles, lowercase on sides. So A over sine A equals B over sine B equals C over sine C. Now, we don't ever work with three things at once, so no two equal signs. So you just pick two. You either use those two, you use those two, or you use those two and set them equal to each other. So you have two sides and they're matching opposite angles. Okay, and then this will work. You could also take this equation, you could flip everything upside down. So sine A over A equals sine B over B equals sine C over C. That works as well. You're welcome to use it that way if you wish. All right, so let's see this in action. Here we have a triangle. We want to solve for all the missing sides and angles. So we're missing angle Z, angle Y, and we're missing side Y. So we need to find all these values. Let's start with what we know. So we have this matching pair here, and then we'll have this pair here, and then we'll end up with this final pair here. We have nothing in cases of the Y, but the X and the Z, we do have some information. So we have X over sine X equals Z over sine Z. We can work with those because we have 15 over sine 80 equals 14.3. There's too many points there. 14.3 over sine Z. So here we go. Let's work this out. We'll do our sines first. So the sine of 80, I'm going to use my handy table here and look up sine of 80. And so I'm going to get 15 over 0.9848 equals 14.3 over sine Z. We'll calculate that. 15 divided by 0.9848 is going to give me about 15.23 equals 14.3 over sine Z. So just like our trigonometric ratios, we have the sine Z on the bottom. We can just flip that with the 15.23. So 14.3 divided by 15.23. Calculate that. And I get sine of Z is equal to 0.9389. I can look that up in my table, and then I have angle Z. So I go through my table under the sine, and we got 9389 coming out to about 9397. It's pretty close, so that is 70 degrees. So I got Z at 70 degrees. So there's a 70 in there. Now, knowing what we know about triangles, the total of all the angles is 180. So Y equals 180 minus 80 minus 70. So Y equals 30 degrees. So I now have angle Y So I found angle Z, I found angle Y, and now I just have to find side Y. So again, we will use the sine law. I'm going to go back to the X here. You can use the pair with the Z as well, but the X will give us a little more accurate of an answer because those are exact numbers. We rounded for the 70. So we got X over sine 80 equals Y, Y, we know the X. 15 over sine 80 equals Y over sine 30. So there's my pairing. We have the sine of 80 again. Well, we know 15 divided by sine 80. Let's just do that right away. 15 divided by sine 80 is going to give us 15.23. And then I got y over the sine of 30. The sine of 30 is 0.5. And then I just cross multiply that. 15.23 times 0.5 equals y. And 15.23 times 0.5 is going to give me 7.66 equals y. So there's my y value. I've now solved for all of the missing sides and angles. So that's the sine law. You're just picking matching side and angles and then doing some cross multiplying and rearranging the equations with a little bit of algebra.